I will speak about these new activities in W3C. Well, first I will introduce a little myself. I'm representing the community group, I'm the co-chair of the community group for high performance web applications. Still, we are defining the name and also the scope. So this is a good opportunity for you to have a look at what we are doing and provide your feedback. Also join this community group. It's under incubation. And the most important part is about high performance and how we can increase the performance of the web engines. Well, with the link as well to AI for sure. So this talk will be for sure about high performance, the web engines, and how this could be applied to this new trend of AI applications and how make the most of the web engines to deliver services and these AI agents on the using the web, using the protocols. So I will present this in two perspectives. One, the high-performance web applications we are discussing in this community group in W3C, and something that is related and some of the existing activities we are discussing as well in the W3C mini apps working group. You know that here we all are using mini apps everywhere, right? But people that we don't live here, we stay overseas, we have some, different paradigms. We are not used to these mini apps everywhere, right? But in this case, we are having some similarities with the high performance activities in W3C and also the mini apps findings and insights we have from the current activities in the mini apps. So starting by the activities we do and the works we are exploring in this high-performance web app community group. As I told you, it's very new. We are still defining the scope, still defining the name. You see that we call it something like a baseline for web apps community group. So we launched this in January this year, and we are still trying to find how we can make the most of the web to create more performant and better user engines. As you can see, I'm one of the co-chairs of this group, and the other one is Mr. Big Zhao, is from Tencent, and he's proposing new topics, new activities, and some disruptive proposals for the web, for these incubation activities. This is part of one post that Vic has posted in the community group. You can have a look at the URL. These slides are on HTML, so you can have a look at all the content, all the resources linked from this. So this is one of the early proposals in this group, discussing how the different applications and frameworks for the web, the top ones are on the cross-platform cross-platform frameworks are delivering and are defining the architectures and also how stable they are. This is a high-level overview of these technologies, starting by the web, rendering using web engines, very flexible CSS to present this, a limited threading model, basically using a JavaScript thread, so a scripting thread model, central thread, and you can also include some web workers. Something to highlight here, according to this Vic Zhao's post, is the layout stability. Very low using the web because of the different modules to implement in the engines, the difficulty to implement altogether this interoperability for the web, and in some cases, the lack of homogeneous representations for the frameworks. And the rest, like native, you see that native for sure is the most stable one, or one of the most stable ones, because it's totally rooted to the platform. And analysis of some others like React Native, mini programs and mini apps, and Flutter. I want to highlight here in the mini programs or mini apps that it's something similar like the web applications. They are using web engines to render the content, and they are using as well CSS subsets. So you see some similarities of the web. Small differences with the threading model, using a parallel logic and rendering threads, different layers, to increase this stability and increase the performance. So this is something that Vic highlighted here in this analysis. And following with the analysis, some personal insights and some proposals that you can have a look, and feel free to comment if you think that this is a good idea. But this is the first approach to define this high performance on the web. As I told you, this is something that is still under discussion, and it's one of the proposals. Something, as I mentioned before, something disruptive, creating a new, it's new and not fully compatible, but it's complementary core for the web. So creating a new set of standards that are not fully compatible with the existing ones, but focus on performance. Adopting something that is very popular from the mini apps, so the possibility to pack and distribute the applications, like the natives as well, but we are speaking in terms of lighter applications, so like the mini apps that are easy to distribute, and yeah, they are lightweight. And in this case also proposing a very decoupled architecture for the rendering part and the logic part. So having something similar like the mini apps. So using messages and events to communicate one layer with the other, or one thread with the other, and making the most of this architecture to increase the performance. And yeah, some other proposals like merging the activities about mini apps and the high performance community group. So, and you will see that it makes, at some point, it makes some sense because there are some similarities about the high performance, what we can do with the high performance, the new web engines, and also the requirements for the mini apps. And linking to this mini apps part, that is something that we have been discussing for 3 years already in W3C, how we can make the most of the light app ecosystem. Very popular here in Asia, specifically in China. So you are familiar to all these logos and the different QR codes, all of the different, no homogeneous representation. It's a very huge ecosystem, but you know that it's not standardized. So this is something that we have been trying to standardize in W3C, establishing new standards for addressing, for instance, instead of having different QR codes, just scanning one, and automatically the platform must know what is this for, and what is the mini app and the super app to use on top of this. So addressing how to create, for instance, the manifest for the mini apps, and some other specifications like how to pack and how to create the components for super apps, and so the mini apps to create it on these super apps. So we are not only having a look at this light app ecosystem in China, but we see that there are not a lot of mini app platform or super apps, but also we have some other similar light app platforms. You can see here some of the super apps that are not in China, but you see that most of them are in Asia. Only a few of them that they are not properly super apps. Like one example is Facebook Instant Games. It's not a proper super app and mini apps, but it's something similar. A light application that you can distribute and you can play on a specific platform. But some others, something similar, like progressive web applications. Progressive web applications are light applications running on the browser. So the browser in this case is acting like a super app, right? So, and yeah, exactly the same for Android, also in Harmony OS or iOS. Something that you can run very easily, quickly, and the application itself is very lightweight. So for these applications that are running, most of these cases running on a web view, and in some other cases something similar, that you don't need the full web for running these applications. Do we need the full-fledged browser or the full-fledged web view for running this? What if we create a smaller, lighter, and more performant web view just for these use cases. So this is something that we are analyzing, and we are thinking how we can do it, or if we should do this this way to solve the problem of the performance. But we also have some other challenges, as you might understand. If you are a developer, if you have I don't know, you are developing a mini app for your restaurant or your shop, and you want to distribute it in WeChat, you do it, you develop in WeChat, or you can develop in some high-level platforms, but you have to distribute it in different platforms, register, submit, do some changes in the code because you have to adapt to a specific payment methods, the specific advertising, whatever you need. So you cannot code once and distribute everywhere. So this is one of the main problems for the developers, the mini app developers. And also the publication. Even if you create a mini app with different distributions using a framework on top of this, you have to deliver it in the different platforms in a one-to-one way. So this is very, very difficult to maintain. So this is one of the main problems. So you cannot distribute everywhere. You cannot code once and distribute everywhere. There are several platforms to do this high-level coding. So Taro, for instance, is one of the well-known platforms here, where you can, using a specific domain-specific language, you can create a generic code, and you can distribute just in one click in HTML5, React Native, and several mini apps. The top mini apps you can find in China. And you can see here, also HTML5. So you code in a meta language, and you generate as well a HTML5. And you will see something, how you can code this. And I don't know if it's well seen from the back, but it's something similar like HTML, but it's not HTML, pure HTML. Basically, you can see some view elements and some image elements with classes, with IDs. So something similar like HTML, and rendering more or less like a web document, but it's not, it's a language on top of this. At the end, this is what you will, what is rendered at the end. Several divs, well, only divs with classes, CSS classes. So you see a very simple way to represent this. At the end, you will see exactly the same as a well-code with proper HTML elements, with the semantics of the HTML elements, but basically this is relying always on CSS. So you code once and you distribute in different places using a meta language and generating something like this, relying on the CSS of the platform. So you see, it's something that we can see the code. It's something that if we can see, if we have the possibility of see the content, it's something that it works for us, more or less, but it's not optimal for search engine optimization and also for the machines to read the content. So exactly the same as in the web. AI that needs to understand these semantics, it's very difficult for them. You know, it's basically plain text with no structure, no semantics in the document. For sure as well, accessibility for these automatic tools that are providing aid for people with some limitations or some difficulties to see or for hearing or whatever, is a problem. Not having the structure of the document, the content of the document. Difficult to port. The portability is a big problem, and also the performance. So it's a very heavy HTML. The final result can be done with HTML very simple, in a very simple way. But we have solutions for all of these. We have the web standards already working perfectly across the top browsers and using the same standards. This is why the web is good right? We have full semantics using the HTML elements. We have accessibility. W3C standards are totally accessibility proven, so it is something that you can rely on them if you apply them to express and to provide the content to anyone independently on the specific requirements they might have and the accessibility needs. Portability, you don't need to do anything, just share the URL and I will be able to access to the content, right? And the performance, if you implement specifically, or you can tweak, you can implement specifically the optimizations to run the HTML code. I know that it's many things of the experts in browser, they know that this is complex, these optimizations, but it's something that, watching at the previous example, if you want to create a super platform, a super framework to create and to distribute these different versions, it's even worse in terms of optimization. So we need a standard for doing this distribution of application, right? And we have some possibilities. Indeed, in 2021, this framework, Taro, proposed a new standard using something like the web, like HTML5, to create the top language, to create the common language to define these applications, HTML5 applications, and also the rest of the mini apps and so on. So they already proposed this in 2021, and it makes sense. This was one of the mapping about the mini app elements, and so the components of the mini apps, the different elements, and let's say the specific map with the mini app, sorry, the HTML elements, the standard ones. And you can see that there is a match, direct match between among all of them, right? Some differences, but somehow can be used, these standards, the existing standards for creating the mini apps, at least in terms of the elements. And it's a good idea, right? So this is why we are in the W3C mini apps working group exploring using this convergence with the web, the existing and the mature web standards to deliver these mini apps. But also, this is something that, as I will mention in a few seconds, it's related to the AI and the performance, how we can create this and how we can iterate on the possibilities we have in W3C and the existing standards to create specific web views for delivering these mini apps or rendering and running these mini apps, and also how we can do it as well with AI. In the case of mini apps, we have a clear dependency of the standards. We have a need of CSS is a subset of the CSS, the standard CSS. The scripting is totally based on JavaScript with some limitations. They limit the execution of some parts of the JavaScript. You don't have full control of this. And the markup, as I showed before, is something similar like HTML. Can be replaced directly, almost directly, with the standard HTML elements. Some differences, the APIs are totally different, but the usage of the APIs are totally different and the architecture is different, but the functionality is exactly the same. You can have access to sensors like the geolocation. You can access to a specific parts of the web view or the browser. So it's exactly the same functionality. So can be replaced by 99% of the standard web APIs. So you can have a look at the gap analysis we have done about the APIs and the elements of the mini apps and the relationship and the match with the existing standards in W3C. So this is just an overview of this map of the standards and the features in the mini apps, and you will see that there is a perfect match in most of the cases. We have heard some complaints about this proposal because they told us that, okay, perhaps this is valid, this is feasible, but perhaps it's worse for developers and for the platform. The developers are used to, or they have more, they have the possibility to use, for instance, icons or scroll lists for doing quicker, the programming, right? So for coding quicker. But you can do it exactly the same with web components. So you have several possibilities, like the web components, and create something like this. This is an embedded, this is an iframe. Well, the style is not good because it was printed as PDF, but this is an iframe using a web component to create an icon for using the web. So you can do exactly the same and having the same functionality. And also creating specific components for the platform, like advertising, or one of the top, in my opinion, one of the most interesting elements in the mini apps is the element map, to create a map to visualize a map with coordinates, the latitude, longitude as attributes, and you have a map with a marker. I think this is brilliant, and this is very, very helpful. But we can do it as well with these web components. And even in these discussions, you can create a specific super apps using the web. So this is one example. You can find the example here. And you can navigate among the different mini apps. It's only a mock example, but you can see that it's performant. It's something very light because it's like a catalog of the menu of a bar, for instance, or a restaurant. It's very simple and can be performant, right? So you can do it with a pure web implementation. And this is something that we are discussing right now. We have the possibility to bring these mini apps overseas because this is something trendy, and many companies are interested right now in monetizing the user base and create better services for their users. So this is something that is gaining traction, and this community here in China, you know how to do it. So this is something that we can leverage the W3C, the web standards, to deliver this everywhere. So this is something that we can explore. Something I've mentioned before, the web standards are already proven, are mature, and they bring security, accessibility, privacy, internationalization by default. So if we apply the standards, it's something that immediately we will have all of these features. And we have right now this mini app working group up and running. Now it's a bit slowing down the activities, but we can keep the pace, and if you are interested in exploring these activities, we can do it this. We are considering the W3C standard right now, the technologies that are booming right now in W3C, like the progressive web applications, exactly the evolution of the web application for a full capable web, but also some possibilities like isolated web apps for packaging and also for distribution with HTTP, and this community group I mentioned at the beginning. So the high-performance engines or the high-performance web applications, or you name it, we need to name it properly. It's totally dedicated to these high-performance engines. So far, we are focused on high performance for this specific use case, the mini apps, or you can find another use case like AI. Do we need a full browser for creating an agent for the web? So perhaps we don't need all the CSS modules, or we don't need all the elements, the deprecated elements in the standards. So this is something that we can trim, we can reduce the set of standards, and we can implement a more performant engine. But this is something that we are still discussing, and perhaps we are wrong. So this is something that we need to discuss with you. So do we need a full-fledged embedded browser or web view for creating a super app, or for creating a chatbot, AI chatbot? So this is something that we are right now discussing. To present the idea, so we have a lot of standards, really heavy implementations in some of the cases, a lot of CSS modules, a lot of APIs that perhaps are not necessary for our use case. So why not we take part of these elements, take part of the CSS modules and part of the different APIs specifically for our use cases. So extracting, depending on the priority, depending on the specific implementation we want to make, or the scenario we want to address, like IoT, like AI, for instance. If we want to create a chatbot, do we need all the standards or just a profile? So this is something that right now we are discussing, and this is one of the proposals as well as the mini app profile. In this case, this is proven that we only need one small part of the web for implementing mini apps. So we can extrapolate this to the rest of the use cases. The new use cases, we are not trying to break the web or make these new implementations against the architecture of the web or backwards incompatible. So this is something that we are also aware of that. So we want to create new use cases on the web, new scenarios, not breaking the architecture or breaking the compatibility in the previous versions. So basically what we need to find is the way to maximize the engine performance in these concrete use cases. And in this case, it's mini apps, it could be AI, it could be IoT. So these use cases that are not traditionally in the web. There are a couple of successful use cases that we can have a look as a reference. One of them is EPUB, so the format for the e-readers, the digital publications. This format is totally based on standards, web standards, CSS and HTML, very reduced. Also the execution of the scripts, very limited. So it's one example that they are trying to maximize the performance for this specific use case, for a specific device, and they are doing exactly the same, collecting different profiles and not implementing the full web for this use case. And another use case is web media for the TV equipment. So for watching TV, you don't need the full, using the web technologies, you don't need the full web implementation. So some ideas how we can develop these profiles. I won't be into the details, but we have tools, we have documentation, we have working groups and community groups to do this in W3C, like the Web DevX, the Developer Experience Community Group, WebViews Community Group as well, trying to define what is the minimum requirement for a web view. So this is something that we can introduce in these different activities in W3C. And we are ready to do this. And as a co-chair of the high performance web or web apps community group, a mini apps community group and working group, and inviting you to join and raise your voice there and contribute with your feedback. We are trying to find the good way to move ahead. So something as a wrap up for discussing with you and opening the floor to you if you have some early comments. First of all, as I told you, inviting you to join the group, but something that we are reflecting. Do we need a new architecture for the web, for these new use cases? Do we break the web? Should we create a new way to deliver the applications with a kind of package? And also this proposal of creating profiles for new use cases. Do we need a specific profile for these use cases we are discussing today here? As most of the examples were very simple, and we don't need the full, let's say, perhaps we don't need all the CSS modules that are very complex to implement if we want to communicate to different agents, if there is no human behind, right? So we don't need the full implementation of the CSS in this case, or the HTML. We don't need anything of this. And if we create something more in an automatic way, without the intervention of the human, or at the end, the interaction of the human, we don't need this final representation for the web. So this is something that we need to consider. So web is everywhere, it's secure, it's accessible, and we have all these good capabilities to deliver the content everywhere to any person and also to any machine. And this is something that we can keep the discussion in W3C. And thank you for listening.